you're in Southern California, you're not. So the fact that some things are going to, knowing what the changes are going to be like is very important. One thing I should point out is that, and maybe we can talk about it later, I think an important issue is adaptation and resilience. Personally, I'm not very sanguine that mankind is going to do anything about global warming. I think we're going to do this experiment. But I think the question is, how do we make it so we're minimally affected as much as possible? That's resilience and adaptation. And I think that is something that needs to be thought about a lot more carefully. We don't have resilience and adaptation to the current climate, as we can see what happened in Oslo and other places, right? We need to think about this much more carefully. We have to do this in any case.
Andy?
Yeah, I think Cliff's exactly right on that. I mean, the climate is changing underneath us, but we're not real good at dealing with the changes that we have already. And when we talk about this experiment being run, scientists are great when we do the experiments. We set up multiple replicates of one thing and we manipulate them in different ways and we see what happens. We only have one Earth, but if we're doing this experiment, we're part of it. We're doing this big experiment now on the Earth, but we have no other Earth to see what's going to happen on as we do this experiment. So this is when I made my sort of flip comment about the physics being the easy part and the human part being the hard part. This is what I mean by it, is that our policies, we have not done a great job with our policies regarding things like water management, or how we deal with fish, how we deal with downstream rights for agriculture. We haven't done a great job with that in a climate that was stable. The idea is that we have a huge learning curve ahead of us in order to get these policies right, in order to provide people with energy services that we all like, and provide people with enough food to go on their plates as we get to a population that's going to hit 10 billion. This is the challenge of our time that I think exceeds sort of any other thing we should be doing. Everyone should be looking real busy right now.
Amy, one thing I meant to mention is this climate change business, to greenhouse warming. This is only one problem, maybe the smallest problem we have to deal with. The real problem is sustainability of our planet. That's the real problem. And the greenhouse gas business, that's only one component of the problem.
Good point. Amy?
I don't know if that makes me feel better or worse, because that's only one and we're not working on it. Adaptation. You distracted me from when I was going to say. Okay, hold on, I'm almost there. Yes, okay. So, one thing that surprises a lot of people that I talk to sort of casually, who ask about what I do and want to know if this is real, and oh my gosh, if it's real, then what the heck is going to happen and who's going to act on this? They're very surprised to hear that there's a lot of action going on in the adaptation realm. So I'm simultaneously really optimistic because there's too much to list, but pessimistic because it's not enough. It's a drop in the bucket compared to what we have to do. But to give you an example, we're sitting here in the Northwest among many of the leading entities at the local, state, tribal, and federal scale who are looking at, in the public sector mostly, looking at the impacts of climate change, the implications on their operations and on their objectives, and asking what risks does this pose, and which ones can I handle, and what's the timeline it's going to take me to get ready for those, and therefore what should I do. So I'm going to put Seattle on the spot because Seattle Public Utilities, Seattle City Light, and the General Office of Sustainability have been looking at this for years, decades. King County, where we are also sitting at the same time as sitting in Seattle, has done this for decades too, looking at climate risks on their operations, reciting their wastewater treatment plant outfalls because they recognize that sea level rise was going to pose a problem for that, and it's cheaper to build them higher in the first place than to move them later. The Swinomish Indian tribal community is a national leader, not only for tribes, but for all entities looking at how climate change affects every single aspect of their planning purview. So there is a lot of good leadership here looking at the implications, and I think we're probably not all surprised to hear that those aren't advertised a lot, but when you open the hood and look underneath, you'll see there's a lot of action going on here and a lot of interesting approaches that are worth following.
I think one of the interesting points that you brought up, shut up.
You don't need a mic.
You can hear me without a mic. That got me in more trouble in high school. I think one of the interesting points is you brought up OSO, and we're preparing a special looking at that issue. One of the interesting statistics that I've heard is that California and Washington are the two leading states, in a way we don't want to be leading, in terms of the number of landslides. And that if you look across the United States, the number of landslides, this is very dramatic, because we had, I think the latest number is 41 fatalities from it. But in fact, in the aggregate, there may be a landslide that kills one, there may be one that kills no one, 2, 3. But talking to one of the geomorphologists, people that study the landforms over at the University of Washington, told me that, in fact, every year there's the equivalent of an OSO magnitude landslide in terms of fatalities. And that was just one of the things that brought home to me, because that sort of represents convergence between geology and meteorology. Let's go, and that sort of leads into what do we do about this? So what I do is, why don't we start with Andy? Maybe take 2 minutes. If you were being asked, what should we do? In fact, you are being asked what should we do. Let's say you were in a position to really make that policy decision. What would it be, or what would they be?
This is, culturally, for me, is a very difficult thing. As being trained as a scientist, I don't feel comfortable talking about what people should do. I think it's a huge, it's something that's drilled into you when you're a scientist. It's about being objective, and as we said, being always true to what the data say. And this is important. But we are at a point where we have these multiple stressors on humanity, of which climate change is a big one, but also changes like things to the nitrogen cycle and this sort of broader aspect of sustainability that does require action. I think that the points that we made here about how the Pacific Northwest might be a nicely isolated, or at least relatively low impact place as climate change, we shouldn't feel smug about that and safe in that. We live in a global world. We have an economy in Seattle, we have an economy in the Northwest that is a global economy. It's dependent on what goes on in the rest of the world. And we need to be thinking about what's going to happen as the climate changes, not just locally, even though our regional impacts are important and we're concerned about whether or not we're going to be able to ski. We need to be very much thinking about what the global impacts are going to be as the climate changes. So I think we have been mired here, and as your series goes on here, it's a fantastic series talking about what the changes in regulations might look like, what a carbon tax might look like. What we have to remember is that it is a global problem and not a national, not a regional problem. It's a global problem, and what are the things we can do to make a global solution? And that's, unfortunately, again, you're starting off with the hardest part. That's the hard thing to do, right?
Well, I think the first thing we got to do is stop this misinformation campaign. I don't know, campaign's the wrong word. There is a huge amount of misinformation about climate change that is coming from both sides, and it is completely distorting the whole conversation. On the denier side, or you call the skeptic side, whatever you want to call these folks, just saying that this having a small amount of this invisible gas can't warm up the planet, it's just nonsense. We know that's not true. So there's nonsense on this sort of skeptic denier side. But then we have the other side, I'll call it the pro-global warming side, whatever you want to call it, okay? Who are making these ridiculous claims that extreme weather all over the world is somehow connected with global warming and climate change. Most of the stuff that you're hearing is just nonsense. Example, for instance, Hurricane Sandy. This is what we would expect under global warming. Well, other than the fact that sea level has risen a little bit, that maybe added a little bit to it, the truth of it is that under global warming, our climate models suggest that Hurricane Sandys will be less frequent. Another recent thing that's been in the media lately is about how aerosols in China are going to increase the storminess over the Pacific. If you read this paper carefully, which I did, I blogged about it, it's all nonsense. Most of the claims about weather becoming more extreme, or more tornadoes, or more whatever, most of these things really don't have any solid backing to them. And so we have problems on both sides. We have hype and exaggeration of extreme events by the pro-warm side, and then we have these claims that global warming is nonsense because an invisible gas at a few parts per billion can't do anything. That's more nonsense. So so we need to get better information to the public. Now, how are we going to do that? I'm not sure. But the media is part of the problem. Anybody from the Seattle Times here? No. I mean, another good example is this whole claim that coastal ocean acidification is killing off the oysters. That's another one that if you actually do the numbers and read through, what's actually happening, that falls away as well. It was due to upwelling, and it wasn't the effect of CO2. So we have all these claims that are without basis, and these hypotheses that are being thrown out there, and the media is headlining it. And I don't know what to do about it.
Let's do the what?
Oh, wait.
What? Upwelling. Upwelling. Coastal upwelling.
If you just, I'll make sure we get back to that and raise your hand and we'll talk about that. Amy.
All right, putting aside my desire to respond to some specific comments Cliff just made. We'll do that later. I want to answer, first I want to answer the question that was posed though. And also echoing exactly what Andy said, which is that as a scientist looking at data and providing scientific projections for use in the public discourse and in public policy making and private sector planning, my job is to be objective and dispassionate. And so what I want to do now is I want to talk about when I look at that information as a person, as a citizen, as a mother, and when I look at what my research has shown me about how well equipped we are to deal with the consequences of a changing climate, I'm going to answer Jeff's question. So first of all, I think we need to get serious about tackling the root cause of the issue. We're causing the planet to warm by emitting greenhouse gases, and we're not stopping that, and we are setting ourselves on a path where under every scenario in the future, we're going to see increased warming. And I'm concerned about that warming because I see what the implications are projected to be on the places that I love here in the Northwest where I've grown up, and I like to ski, and I like to hike, and also on the systems that we've developed to maintain our economy and our lives, where we've built in proximity to flood zones or to the coastline, how big the reservoirs we've built to produce our hydropower. All of these things are not going to function as well in a changing climate. And so we need to think seriously and start acting on the root cause of the problem. And we need to get very serious about adaptation and about looking at what our risks are, clear-eyed, cold-hearted, and dealing with them even if we don't like what they look like.
Thank you each very much. How are you doing on throat? Would you like to maybe we can take some bottled water or glasses of water? You've all been very patient, and everybody still looks very attentive as I've been looking around the room. But let's open it up to questions that some of you might have. And we have a microphone circulating back there. As you raise a hand, I've got one over here. Why don't we take questions from that gentleman first?
I just got back from 3 weeks in China. It's my 4th such trip over the last dozen years, and Beijing is dirtier and dirtier every time I go, and their financial success is killing their population with, and I don't know any, I'm not a scientist, with currents, air currents and everything else, and you're talking about more and more rain, or, you know, will that acidify the air enough where it will affect our crop? Will it affect fish flow in the rivers and all that sort of stuff?
I sort of split that into maybe 2 points, and whoever wants to respond to that. The impact directly in terms of acidification, and we might also bring up, let's say we adapt or take measures that we really need to here in the Northwest. Is it going to make a difference if other nations do not do similar things?
Okay, so yes, yeah, great question. So, lots of questions there. So first of all, CO2 or other greenhouse gases put into the atmosphere anywhere in the world end up in the atmosphere everywhere in the world. So emissions anywhere are important for global warming and will affect our climate. Similarly, for that CO2 to be absorbed by the oceans contributing to ocean acidification, it doesn't matter where it's emitted, it still has a global effect. You can talk more about sort of weather and actual atmospheric particulate pollution, if you like. So we are all on the hook for the CO2 in the atmosphere now and into the future. One of the things people often bring up is why can we do anything here if the rest of the world or the developing world is going to emit quite a bit more going forward. And I think that there's two parts that I think of when I think about that question. And one is we have already emitted as a society a huge amount of fossil fuels, right? So, and we've increased atmospheric CO2 alone by 40% since prior to the Industrial Revolution. And the bulk of those emissions have come from the developed world. And so at any one time, it's important to look at who has contributed to the problem overall, not just who contributed to it this week. The other side, what was the second part of the question? It was about can we do anything here and what happens if the rest of the world doesn't do anything? I think again, there's many dimensions to the answer there. One is about on the emissions side. If we do anything to reduce our emissions here as a city of Seattle or the state of Washington and the whole rest of the world doesn't change anything, are we going to save ourselves from these impacts I've talked about? Not one bit. But the problem, one of the reasons this is such a challenge, climate change, global warming, is because there's no one silver bullet and there's no one bad guy. We're all the bad guys, right? And so making a difference requires effort across multiple sectors, multiple locations, and multiple parts of the economy.
Anybody else want to offer a perspective on that?
Well, we have someone here at the University of Washington, Bothell, Professor Dan Jaffe, has done extensive observation of what's coming across the Pacific. And some of the aerosols and some of the gases that are produced by combustion in China are getting across. And so roughly 10 or 15% of our air pollution around here can be traced back to Asia. And China's number one, India's there, so we are getting it. And as Amy says, it doesn't matter who puts it up. It's still the same thing. But, you know, getting to the pragmatics, you know, there's a lot of talk about coal trains. Well, you know, we're talking about shipping unimaginable amounts of coal to China, on the order of 150 million tons or something a year, something really large. Well, quite frankly, if we're doing something like that, you know, you don't worry about your Prius. I mean, you can drive Priuses and get your solar array on your roof. You're just wasting your time if we're shipping 150 million tons a year to China. You can't do both. You know, that completely eclipses anything that we do here. So if we're going to do something that's going to make a difference, we're going to have to affect China and India. And to me, that means we have to develop the technology for energy conservation for the future here that we can give to these other nations so they don't use as much energy. To me, that's the way that we make progress, not driving your Prius down the road. They feel good, but it's dealing with Asia that's really going to make the difference when this planet warms, not what happens here.
Do we have any Toyota dealers here? Andy, did you have any perspective?
I would echo what Amy and Cliff said. We have the chance now, as a leader in the clean tech and energy spaces economically, to be the drivers of what happens to the planet over the next century. And we can do that. And when I say we, as a feckless academic, I don't mean me. I mean you in the crowd can actually be the clean tech guys out there. You can decide if this is what we want to do or not. I will, you know, continue to pontificate about it. But it's up. It really is. It's up to the business community to get us out of this one.
Next question. Why don't we, gentlemen, right here, and tell you what I'm close by.
I was very interested in the discussion of the ensemble forecasting. And as you know, the IPCC does scenarios, and James Hansen did scenarios in his work. And I wonder if the scenario idea is similar or identical to ensemble forecasting, or if there are some differences.
Okay, there's only one component of it. I mean, there's all kinds of uncertainty. One uncertainty is how much greenhouse gases we'll put in the atmosphere, okay? And that kind of uncertainty, that's dealt with by the scenarios, okay? But there's also other uncertainties, like uncertainties in how physics parameterizations work in the model, or how we do numerics in the model, or how the resolutions of the model. So there's a tremendous amount of uncertainty. Even if we knew exactly what mankind was going to be putting in the atmosphere the next century, there's still huge uncertainty because of our modeling has a lot of uncertainties. So that's what I'm talking about.
But let's just talk about how wide those uncertainties are, right? So again, those uncertainties aren't big enough for us to say it might cool, or it might not warm at all, right? So they're in the amount, the magnitude and rate of time, of temperature increases. And one other thing that I'd like to mention briefly that ensemble forecasting or ensemble climate modeling brings to us is it helps us look at the added contributions from our uncertainties in the physics and the modeling itself that Cliff mentioned, but also the uncertainties in how our climate's going to vary. Okay, so we know we have a very variable climate here. We have really wet years, really dry years, really wet decades, really dry decades, and we're going to still have those in the future. And so you need to run, for the first case, a lot of different climate models to see how they tell you about different climate physics and what predictions they give. And then for each climate model, you need to run it a whole bunch of times to see how it thinks the climate's going to vary. And so that's actually what's done, and these results that are presented are a sort of snapshot of what I can give in one mouthful of the results of looking across all of those different areas.
Anybody else? Yeah, I'll pass on that. Gentleman over here, if you take the microphone.
Thanks. So I'm an engineer, and my job is to take what you scientists do and apply it to the real world. And oftentimes what that means is having to educate a client, and in particular recently, I've been working on a document that will go into the public domain. It actually has to do with the coal project that you're referring to. And what I found is that trying to explain uncertainty is incredibly difficult. And people, the general public, do not, it's very difficult to, people don't like uncertainty, essentially. And so maybe this is, I invite anybody to answer this question, but Mr. Renner might actually be the best responding to somebody that talks to the public on a daily basis. How do you best educate the public to, when you're talking about uncertainty, which is something that, in my brief experience, is a very difficult thing to explain?
It's something that we're playing with because I'm in conversation with a variety of people. Cliff and I talk about this. American Meteorological Society, the broadcast section of which I serve on a panel, we're talking about that. And it depends on the types of weather, but one of the things that we try to do to get a sense of the relative confidence, if you will, sort of the flip side of uncertainty, is to use sort of like a series of diagrams and have it going from up to red if we're very confident something's going to happen, yellow if we're moderately confident, green if we're less confident. And we have found in tracking studies with interviews of people that are viewers that gives them a bit of a sense. I think there is definitely a lack of, what shall I say, receptivity to the concept of uncertainty, like you mentioned. But I think if you present it, and it takes a lot of insight, and I gave you one method we're doing, and we're not there. I think as we develop better means of portraying that and giving analogies and so forth, I think they'll be able to respond to that better. Cliff?
I think this uncertainty thing is absolutely crucial, because if we give a single forecast and we're wrong, we look bad and people aren't going to believe us, right? But if we reveal the true uncertainty that's there, and as long as it's within the range of uncertainty, we still have some credibility. So I think for our own credibility, if we're going to get people to do what's necessary, we have to give them the uncertainty. If we have these over-certain forecasts, we're going to run into trouble. Just like the people 10 years ago who were saying that by 2020 the snowpack in Cascades was going to disappear by 50%. Well, they're going to be completely wrong. If they had shown their uncertainty, then they might have had some credibility, which they've lost. I should mention that people are used to uncertainty when it comes to medicine, right? You go for various treatments, they tell you what the range of possibilities are, and probabilities of cure, and things like that. When people are doing gambling, they're used to probabilities, right? So, I mean, we can do it. But we need help of social scientists to help the weather and climate community to better understand how to communicate this kind of information. That's something that we have not done sufficiently, and we need to do in the future.
And I would add to that, part of it is communication. One of the problems that you'll see is you'll get a tendency for people to attach themselves to sort of a headline version. What we need to do as communicators, whether it's as you are as an engineer or those of us that are meteorologists, etc., is find a way to engage their attention all through the presentation so that they listen to all of the details. Let's see, any questions over here?
Sure. My name is Natalie Jamers. I work with Washington Environmental Council. I'm really interested about how you as scientists feel limited or propelled to act outside of your scientist role. Andy said he was not comfortable talking about what people should do because that's not what you're trained to do. And I wonder what opportunities you feel already exist or what you wish could exist to let your voices be heard and amplified outside of the academic community or scientific community, such as in public hearings or testifying as a mother or as an uncle. What do you wish you could do more of to let your voice be heard on a more citizen, in a citizen way rather than just as an academic?
I do. I'm not sure I feel, so I think my comments were referring to the professional norms and my need to distinguish the genesis of comments, right? So when I'm standing up here presenting numbers and projections for how the climate will change in the Northwest and presenting the results of research that shows that in some areas we're not well equipped to deal with those because we haven't dealt with similar things in the past. I want to be very clear when I present those things that those findings come from a lot of research and hard numbers, and you can go look them up. And when I talk about other things, I'm a well-educated layperson about what policy might work or how fast we ought to act as a society. And frankly, I feel that there are many opportunities for me to voice those, engaging as anybody would in a civic life.
Yeah, this is a very difficult question because, if we get too far into advocacy, then we could lose the ability to talk to everyone. And, I've seen that happening a little bit already, that we just have to be very careful here. I mean, in our private lives, I think we can always, push what we believe in. But in our professional lives, I think we have to keep away from advocacy to some degree, or we lose credibility with one side or the other. I mean, it's very important to speak to both sides of the aisle, and so we can't become over-politicized.
I agree with that very much, but I also think that doesn't hamstring us in what we can do as when we talk about things that aren't science, because there's plenty of common overlap. People across the political spectrum love renewable energy. They love energy efficiency. There's things that you can talk about. You have to be always explicit about what you do and what your science says. But there's plenty of places for people to agree, and the scientists don't want to fall into the trap of going into advocacy on things that are divisive, because that will make people stop listening to you. But there's plenty of space for us to talk to everybody and share what we know that isn't politically divisive. And I think. For me personally, that's the direction I go in. Is I'd say, where let's find out what we agree on and work on that, because God knows there's plenty of people out there to disagree with, and you can find someone to disagree with on your own time. Let's talk about what we can agree on.
Okay, next question.
Sure. Hi, I'm Deb Rednick. I'm the chair of the Bainbridge Island Watershed Council, and I want to thank you so much. This has been really interesting. I heard a lot of discussion about some of the hydrologic and precipitation-driven changes we might expect. I didn't hear a lot of discussion about what we might expect in the future for oceanic chemistry changes. I know Cliff touched on that a little bit. That's not exactly the popular narrative I'm used to hearing. So I was wondering if you could spend a little bit more time talking about oceanic chemistry and what we might expect regionally and on broader scales.
Since you already did.
Well, I got more to say.
So ocean acidification is sort of another side, another dimension of climate change, right? So the CO2 that is emitted to the atmosphere, about 30% of it stays in the atmosphere, and the rest is taken up by the ocean and plants on the land surface. And that's always been thought of until recently as a really great thing, because we would have experienced quite a bit more warming, and we'd be in store for incredible warming if the ocean didn't take away 70% of our impact. The flip side of that, though, is that as CO2 is absorbed in the ocean, because of the ocean chemistry, it decreases the pH. It moves the ocean towards acidity, but nowhere near it. So this is the complication. So the oceans are typically alkaline, which are not acid. The absorption of CO2 makes them less alkaline, makes them more acidic, although not acidic. And we know that this is important for calcium carbonate forming organisms in the ocean, like corals, like pteropods that salmon eat, like oysters, because they form their shells from calcium and carbonate in the ocean, and the energetic requirements for forming those cells are different depending on the pH and the other chemistry levels. And so what has been observed, and Cliff mentioned upwelling, we live right here on the edge, on the eastern edge of the North Pacific, where due to atmospheric circulation, we have upwelling, which means that we have deep water coming up from the bottom, or depth, not all the way to the bottom, near our shores. So the water right off our shores is from deeper levels. And it's quite high in this, it's low in pH. It's high in hydrogen ions. So natural. And there's natural variations in this upwelling. So we have times when the water is essentially more acidic and times when it is less acidic because of these variations in the atmospheric and ocean circulation. We know that biological organisms are sensitive to these amounts. So we know that naturally those variations have made it hard for organisms to form their shells when they're in vulnerable stages, like oyster larvae. So it doesn't happen to all oysters at all times. Grown-ups just might, it's an undetectable change on grown-up oysters. But on the baby lobsters, the larvae, there already is difficult times for them. And then if you add additional CO2 to the waters, it can push, it can make those bad days happen more frequently, or it can make a bad day worse. So if you think about a bad day for baby oysters as a day when upwelling caused lower acidity waters to come into contact with them, this is something that happens more frequently with the atmospheric CO2 that has decreased the acidity of the waters.
Okay, I want to talk about this. The ocean acidification is a serious issue. I mean, as we increase CO2 in the atmosphere, the oceans will become more acidic, well, less basic. Okay, it'll never be acidic. Never be acidic. It's always going to be alkaline. Okay, we're talking about a pH that's dropping will never be acidic. Okay, now there's been a lot of issue about these oysters. And Seattle Times had this big story about oysters along it, right? Those were never in the natural environment. These were oysters in these tanks along the coast, in which they were growing a non-native species in artificial conditions in these big tanks. And they made a mistake. What they would do, during some periods in summer, we have a strong upwell, okay, which means the water comes upward. It has a lower pH and it's colder, okay, less oxygen. They sucked it into these tanks at the wrong time, and that affected some of the oysters, little baby oysters in their tanks, okay? Now, what you have to understand is the CO2 that's coming up in this upwelling is 40-year-old water. This is water that was exposed to the atmosphere when CO2 was much, much less. If you do a simple calculation, you find that the change in pH due to human intervention for these cases that affected those oysters in those tanks was extremely small. These oysters would have had little baby oysters would have had problems anyway. Then these guys, they changed their way they started doing the water. They pulled it in later in the day, after photosynthesis was working, and then they didn't have any problems anymore. So the oyster larvae problem has gone away. No more problems. You can talk to the oyster people, they'll tell you this, right? And there was never a problem in the interior waters of Puget Sound. There was never an acidification problem there. So this is a whole thing that has been hyped by the Seattle Times. And it really has nothing to do with greenhouse warming. It has to do with upwelling and pulling the water in the wrong time in an absolutely artificial environment. That is true.
If we may, and just knowing where we're getting on time here, I don't want all of you to walk out and say I went to a fascinating symposium on oyster reproduction. So we'll try to offer some pearls of wisdom on another topic. Gentlemen over there. Oh, microphone back there, and then we'll hit your question.
Hi, my name is Elizabeth Nicolo, and I want to just ask about impacts on food systems with ocean warming and impact on ocean ecosystems and food chain, and then also impacts on land. If, for instance, California's Central Valley becomes drier, what does that mean for food production? Thanks.
So let's see, I'm not sure if anybody here can answer the question on a global ocean food production and impacts of climate change. I think I could talk about what the major ways we think it will affect that, but I can't talk about, because I don't know, the sort of aggregate projected impact. So if you think about food production from the oceans, ocean acidification is, the biological implications of that across the food chain are not known. And this is one reason we have a new Center on Ocean Acidification at the University of Washington, just funded by the state this year, to try to start to disentangle those biological effects. The chemistry's the easy part, and the biology is harder. There's the challenges for ocean acidification, changes in temperature, so the oceans have warmed quite a bit.